Am I audible? Is audio video clear? Right. Yesterday I have explained you what are linearly independent vectors, linearly dependent vectors. Linearly independent vectors, linearly dependent vectors. Just by comparison. If you compare two vectors, if one vector is possible to express scalar multiplication of other vector, then they are dependent. If it is not possible, then they are linearly independent. Suppose more than Siddharth, rank of A plus rank of B 9, rank of A plus B less than or equal to rank of A plus rank of B. You have to understand one point. The meaning of that property is rank of A plus B never be greater than rank of A plus rank of B. Not greater than rank of A plus rank of B. Rank of A plus B not greater than rank of A plus rank of B. Either less than or equal. That is the meaning of that statement. Okay. Now, let me explain the other methods to examine whether the set of vectors are linearly independent or dependent. Yesterday I have explained you, if you would like to know whether given set of vectors are independent or dependent, arrange them in a matrix, calculate rank of the matrix. If rank is n, then all the vectors are linearly independent. If rank is less than n, then the set of vectors are linearly dependent. I'll explain once again. Generally, 90% of the students get confused in the case of linearly dependent. I'll explain again by taking the example. Observe. If det A not equal to 0 or rank of A is equal to n, then the set of vectors, one minute. If det A not equal to 0 and rank of A is equal to n, the set of vectors are linearly independent. Rakesh, this is the first slide. If det A equal to 0 or rank of A less than n, then the set of vectors are linearly dependent. I have to explain here this point, especially this point. Why? Because most of the students get confused here. Sir, yesterday you said, Avdesh, I am explaining, you have to wait. I have not even started example. The set of vectors are linearly dependent means you have to understand one point. At least one of the vector is dependent. At least one vector is dependent. Then the set is called dependent. Concentrate here. Sir, I have given 10 vectors. You have arranged in a matrix. You have arranged all 10 vectors are in a matrix, because first concentrate on the content, what I am explaining. Next you can copy. Okay. Now, if you come late, concentrate on the content. Arrange the vectors in a matrix like this. Calculate the rank. If the matrix is 10 cross 10, if rank is 10, then if rank of A is 10, then all 10 vectors are linearly independent. Then the set is called set is linearly independent. Set is linearly independent means set of vectors are linearly independent. Set of vectors, the set of vectors is linearly independent. That is the meaning. Here no doubt. Because sir, I have given 10 vectors, you have arranged in a matrix, you got rank 10. Therefore, all 10 are linearly independent. Clear. No doubt about this. But in the case of a matrix is 10 cross 10, you have arranged all 10 vectors, reduced into echelon form. You found that rank of A is 7. What does it mean? What does it mean? 7 linearly independent vectors. 7 linearly independent vectors. So 3 are linearly dependent vectors. But please remember, but while writing in a statement, we are going to write the set of vectors. The set of vectors is linearly dependent. Here, some students get confused. Sir, you already told that rank is 7, so 7 are linearly independent, but you have written here set is linearly dependent. In the previous case, matrix is 10 cross 10, all 10 are linearly independent because rank is 10. There is no dependent vector in your set. That's why set is independent. But here you have 3 linearly dependent vectors. Even one vector is linearly dependent in your set. The set is called dependent. So, sir, set of vectors linearly dependent means all are not linearly dependent. Set dependent means some independent, some dependent. Sir, how many are independent? Rank will teach you. Rank will give the clear picture about how many are independent among the given set. That is the concept. Okay. Ranjit, mathematics में English, Hindi कोई फर्क नहीं. Okay? You concentrate on the content. You can understand. Now, set linearly dependent means some independent vectors in the given set and some dependent vectors are in the given set. How many are independent? Remaining are dependent. Okay? Mohammed, if you join today, better to follow first lecture onwards. You won't get anything. Today we are in the middle. Right? Next, same thing I have given in this definition. If rank of A is n, set of vectors are independent. If rank of A is less than n, set of vectors are dependent. The reason is determinant is 0, rank is automatically less than n. If determinant is 0, rank is less than n, that's why at least one vector is dependent. That's why the set is dependent. If rank is non-zero, a rank is n, or determinant is non-zero. If determinant is non-zero, rank is its order. Na? So rank is n automatically. So in that case, all the vectors are independent. That's why set is independent. Okay. Now I'll give the examples. Sir, what is the? I am giving the example, Nandini. Wait. Sir, what is the difference between rank procedure and determinant procedure? You can understand now. I'll give the example. First example. X1 is 1, 0, 0. X2 is 0, 1, 0. X3 is 0, 0, 1. Now, if you arrange all the vectors in a determinant, either row wise or column wise, doesn't matter, because rank of A and rank of A transpose are same. Determinant value of A and determinant value of A transpose are also same. Now, if you arrange in a column wise 1, 0, 0, 0, 1, 0, 0, 0, 1, what is determinant value? 1, non-zero. If determinant is non-zero, set of vectors is linearly independent. Okay, suppose if you arrange all the vectors in matrix form like this. Is it in echelon form? Yes. Therefore, rank of A is 3. Therefore, rank is its order. Therefore, they are linearly independent. Now, you have to tell me, what is the difference between determinant procedure and rank procedure? What is the difference between determinant procedure and rank procedure? Vivek, already it is in echelon form. What is the need of reducing? थोड़ा सोचना पड़ेगा आपने. It is already in echelon form. After getting echelon form, what you are going to reduce? Very good, Pankaj. Very good. Determinant procedure gives us idea about whether set is independent or dependent. But rank procedure gives us exactly how many are independent. For example, 1, 0, 0. X2 is 0, 1, 0. X3 is 9, 5, 0. Okay, suppose if you arrange in a determinant 1, 0, 0, 0, 1, 0, 9, 5, 0. If every element of one row is 0 or one column is 0, the value of determinant is 0. If determinant is 0, set of vectors is linearly dependent. Set is dependent. Now, if you calculate rank, in this case, 1, 0, 0, 0, 1, 0, 1, 0, 0, 0, 1, 0, 9, 5, 0. Is it in echelon form? Yes. Rank of A is 2. Therefore, 2 linearly independent, 1 linearly dependent. I have to explain one point here. I have to clarify here. Some students get confused here. Sir, 2 are independent, 1 is dependent. even at least one is dependent, the set is dependent. Clear? Sir, in this example, can we know that which vector is dependent vector? Whether x3 is dependent or x2 is dependent or x1 is dependent? Which one is dependent? Please remember, you can't estimate which vector is dependent. You can't estimate which vector is dependent. You can estimate only how many are independent, how many are dependent. Please remember. Sir, why it is so? Why can't we say third vector is dependent? Suppose one student is arranged, third vector in third column. Another student is arranged third vector in third row. Sandeep has arranged third vector as a first vector as a third vector. If you reduce in echelon form, last row becomes zero row, na? That's why you can't say which one is dependent. You can say how many are dependent, how many are independent. Please understand this point. Okay. Suppose Vikas had arranged third vector as a first vector in echelon form. While applying echelon form, last row becomes zero row. Then, sir, zero vector is a dependent vector. You said yesterday. I said zero vector is called dependent vector because it becomes zero row by applying some operation, means it is depending on some other row. Because of that dependency, that becomes zero row. That I said. But I never said this vector is dependent or this vector is independent. I said rank gives you idea about how many are independent. Okay, please understand this point. Okay, so by determinant procedure, we can understand whether set is independent or set is dependent. By rank procedure, we can understand how many are independent vectors among the given set. No method gives us which vector is dependent. No method gives us which vector is dependent. Okay, please understand this point. One student can write x3 in the form of 9x1 plus 5x2. Sir, x3 can be written as 9 times of x1 plus 5 times of x2. It is in the linear combination. It can be written as alpha x1 plus beta x2. Therefore, x3 is dependent. You can't say like that. Not only x3, x2 can be written as combination of x1, x3. x1 can be written as combination of x2, x3. That's why you should not say one vector is dependent and other vector is independent. You can say only when you can say how many are independent and how many are dependent. Please remember that point. Next. So till now you have learned three methods. Three methods. One is by comparison how to check independent and dependent, by determinant how to check independent and dependent, by rank how to check independent and dependent. Now fourth method, definition. First I am explaining the definition. Next I will come to next I will explain with example. Okay, write the definition. Linearly dependent vectors and linearly independent vectors. Linearly dependent vectors. If you are new, better to follow from lecture 1 onwards. Otherwise, you won't get anything. Linearly dependent vectors. the vectors x1, x2, xm of same degree, order is nothing but here dimension, okay, are said to be linearly dependent if there exists scalars, if there exist scalars k1, k2, km, not all zero, such that k1 x1 plus k2 x2 plus km xm equal to 0, where not required. K1, K2, Km are all scalars I have mentioned clearly. Okay. The set of vectors x1, x2 and so on xm of same dimension are said to be linearly dependent if there exist scalars k1, x1 plus k2, x2 plus km xm equal to 0, where k1, k2, km not all 0. Sir, what is not all 0? At least one scalar is non-zero. Not all 0 means at least one is non-zero. At least one is non-zero. Not all 0. K1, K2, Km, not all 0. This is the keyword. Now, linearly independent vectors. Linearly independent vectors. Definition. The vectors x1, x2 and so on xm of same order n are said to be linearly independent if there exists scalars k1, k2 and so on km, k1, k2, km, such that k1 x1 plus k2 x2 plus km xm equal to 0 implies k1 equal to 0, k2 equal to 0 and so on km equal to 0. What does it mean? All are 0, not non-zero, all are 0. All ki's are 0. If all ki's are 0, then the vectors x1, x2, xm are linearly independent. Because you will get the idea only when if I explain with the example. Directly by reading the definition even 10 times, you won't get the idea. Observe. For example, x1 is 1, 0, 0, x2 is 0, 1, 0, x3 is 0, 0, 1. I am taking known example. Why I am taking known example? In that method, we got independent. Here also you will get independent. In that method, if you get dependent, here also you will get dependent. Okay. Now, observe. In this procedure, what we have to do? You have to write linear combination form. K1 x1 plus K2 x2 plus K3 x3 equal to 0. You have to take like this. Now, K1 multiplied with x1, 1, 0, 0. K2 multiplied with x2, 0, 1, 0. K3 multiplied with x3, 0, 0, 1 equal to 0 vector. Sir, what is that 0 vector? If x1 is of dimension 3, x2 is of dimension 3, x3 is of dimension 3, 0 is also of dimension 3, 0, 0, 0. Okay? Because if LHS is with dimension 3, RHS is also with dimension 3, then only you can equate two vectors. Okay? Now, observe. K1 multiplied with 1 plus K2 multiplied with 0 plus K3 multiplied with 0. What is the result? K1. K1 plus 0 plus 0. Okay. Next. K1 multiplied with 0. K2 multiplied with 1. K3 multiplied with 0. I am talking about this. Second entry. Okay. K2. Third entry. 0 plus K, 0 plus K3. K3 equal to 0, 0, 0. If you equate LHS with RHS, what is the conclusion? Conclusion is K1 is 0, K2 is 0, K3 is 0. Therefore, all the scalars are 0. Therefore, the vectors are linearly independent. Therefore, x1, x2, x3 are linearly independent. That is the definition. Okay. Mr. Chaudhary, here matrix is considered as vector 9. Here vector is considered as vector. Row vector or column vector. Row matrix and column matrix are known as column vector and row vector. First lecture I told you clearly. Okay. For dependent also same logic. It is not tough. What happened? Here you have to write one vector in the form of combination of other vector. That is the only thing. In the case of dependent, you will get arbitrary element. Understood? Actually, in all these four methods, the best method is rank method. Arrange the vectors in a matrix, calculate rank. Rank gives you clear picture about how many are independent and how many are dependent, whether set is dependent or set is independent. Okay? So better to follow rank procedure. Now, another concept we have, that is basis. Basis. So what is basis? First I am giving the definition. By reading the definition you won't get anything. Don't worry. I will explain with example. Yes, Pathak. In a dependent case, at least one scalar is non-zero. Not all zero. Not all zero means at least one is non-zero. So in this class, not all boys means at least one girl is there. Not all zeros. not all zeros, means at least one non-zero entry is here, like that. Basis. A finite subset B of vector space V is called basis for V if, first condition, B is a set of linearly independent vectors. Number 2, B spans vector space V. What is the meaning of the second line? Sir, what is spans? That means, I am writing in detail. The meaning of this statement is, that is, every vector of V is a linear combination of vectors of set B. If every vector of V is a linear combination of vectors of set B, you can say that vector space V is spanned by set B, or B spans vector space V. B spans vector space V is nothing but vector space V is spanned by vectors of B. Vector space V is spanned by vectors of V means every vector of V is possible to express linear combination of vectors of B. Observe the example. For your understanding purpose, I am starting with simple example, plane. I am taking just plane. Plane means this is a plane. Is it a plane or not? Akhtar, I know that it is not clear. Only by example you will get the idea. Okay? Observe. XY plane. Very good. Rakesh. XY plane. Any vector, if I take any vector in this plane, suppose the vector is A comma B. Sir, vector is A comma B means AI cap plus BJ cap. Clear? Understood? So, any vector if I take in this two-dimensional plane, that vector is possible to express in the form of AI cap plus BJ cap or not. Suppose if you take 7 comma 9, 7 comma 9 means 7I cap plus 9J cap. Understood? This can be written as 7 into 10 plus 9 into 01. Any problem? Sir, what are 1001? 1 0 is nothing but I cap, 0 1 is nothing but J cap. Okay, so this is nothing but 7 9 or not, 7 9 or not. So any vector of this two-dimensional plane, any vector of this two-dimensional plane can be represented in the form of A into 1 0 plus B into 0 1. Sir, what are A and B? A and B are real numbers. Whatever real numbers you have taken, those real numbers. Suppose if you take 6 comma 9 or minus 6 comma 9, no problem. You can write minus 6 into 1 0 plus 9 into 0 1. Any vector you take, you can express in the form of minus, in the form of ai cap plus bj cap, or a into 1 0 plus b into 0 1. Okay, now if you write this 1 0 and 0 1 in one set, a set consisting 1 0 and 0 1 is called basis for a two-dimensional vector space. Sir, how can you know that V is two-dimensional vector space? For better understanding, I am going to write R square. Sir, what is R square? You have taken two real lines, x-axis, y-axis. X-axis is one real line, y-axis is one real line. It is a Cartesian product of two real lines. That's why it is represented by R square. Okay. So a set which consisting 1 0 0 1 is a basis for a two-dimensional vector space V. Clearly, this basis satisfies two conditions. First condition is the vectors are independent. Yes, arrange the vectors in a matrix. Calculate determinant value. Non-zero or zero? Non-zero. So first condition is satisfied. The vectors are linearly independent. Now, second condition. Sir, what is second condition? Every vector is possible to express linear combination of vectors of set B. If you take one vector AB from your vector space, from your two-dimensional space, you can express A into 1 0 plus B into 0 1. Here 1 0 0 1 are nothing but vectors of set B or not. Okay. So first condition is satisfied. Second condition is also satisfied. Therefore, B is a basis. Mr. Chaudhary, you are not getting the concept. You are continuously asked, sir, why you are taking row vector, why not column vector? If you want row vector, you write as a row vector. Doesn't matter. Row vector, column vector is not matter. Here, what is the matter? You have to understand which one is basis. Okay, next example. Row vector, column vector, क्या फर्क है? कुछ भी नहीं. Yeah, I am going to write like this in row vector. In column vector, I am going to write like this. Nothing. Only thing is you require this. Observe. A vector space V equal to A, B, C such that A comma B comma C belongs to R. Sir, what is this? I have written vector space V in the form of a set builder form. ABC indicates a three-dimensional vector. It is a three-dimensional vector. Sir, what are ABC? ABC are real numbers. It means I have taken a three-dimensional vector space. Generally, three-dimensional vector space is represented by R cube, x-axis, y-axis, z-axis. Length, breadth, height. For your visualization purpose, you have to imagine like that. Okay, so I cap, j cap, k cap are the base vectors to create one three-dimensional space. If you want to create one three-dimensional space, you have to take three vectors. What are the base vectors to create one space, three-dimensional space? I cap, j cap, k cap. Understood? If you write I cap, j cap, k cap, all these three base vectors in a set. I cap generally represented by 1 0 0, j cap 0 1 0, k cap 0 0 1. Okay, now the set B consisting of three vectors. Sir, why you have taken three vectors? Why not four vectors? If you want to create a three-dimensional vector space, you require only three base vectors. If you want to create four-dimensional vector space, you have to take four base vectors. Yes, I cap, j cap, k cap, I mean x, y, z. Fourth dimension is time. Okay, like that you can create a four-dimensional basis for four-dimensional space. Four base vectors are required. Okay, now here I have taken three base vectors in one set. Now I have to prove that B is a basis for vector space V. To prove that a set is a basis for vector space, I have to prove two conditions. First condition is whether the vectors of set B are independent. That's why I am taking all these vectors in one matrix. What is determinant value? 1, non-zero. Non-zero matlab independent, linearly independent. The set of vectors are linearly independent. B is involving linearly independent set. Now, what is second condition? Every vector of V is possible to express linear combination of vectors of set B. Suppose if you say vectors of B are x1, x2, x3, you have to write every vector of V in the form of alpha x1 plus beta x2 plus gamma x3 form. Here, if you take a vector from your vector space V, A, B, C, you can write A into 1 0 0, B into 0 1 0 plus C into 0 0 1. A x1 plus B x2 plus C x3 form. Clearly, the vector of V is expressed in the linear combination of vectors of B. Therefore, B is a basis. B is a basis for vector space V equal to R cube. R cube matlab three-dimensional space. Raju, R cube means three-dimensional space. X-axis, one real line. Y-axis, another real line. Z-axis, another real line. Combination of three real lines, Cartesian product of three real lines, create one three-dimensional space. That's why it is represented by R cube. R power n means n-dimensional vector space. That is also known as n-tuple. Understood? Mukherjee, three base vectors, that's why it is not R cube. Because of R cube, you have taken three base vectors. Your vector space is of three-dimensional, that's why you require three base vectors. Because, why not possible? Time is fourth dimension. Infinite element methods is completely depending on this concept only. N-dimensional is an imagination concept. Okay? Now, understood? राजू कितना बार बोलना R cube V equal to R cube मतलब vector space V equal to R cube. Vector space is three-dimensional vector space. That is the meaning of that. Actually, I have to write V. I have mentioned R cube for your better understanding. R cube is just a representation. Sir, what kind of questions will come from this concept? Actually, this concept is foundation of eigenvectors concept. You are going to write eigenvectors corresponding to eigenvalues. So what are eigenvectors? If you understand what is eigenspace, you can understand eigenvector concept. Okay, this basis concept is foundation of eigenvectors concept. Actually, some faculties informs you basis is not important, it is not mentioned in the syllabus. It is the foundation they won't mention. You have to understand the basic concept of eigenvectors from this basis concept, especially eigenvectors corresponding to repeated eigenvalues you are going to found by using this concept only. Now, Janaki Patel, it is imagination. You have to imagine. I have mentioned clearly space. If you take one point in the space, that point you have to express in the form of, suppose your point is 2, 3, 4. How you are going to express? 2i cap, 3j cap, 4k cap. Means what? I cap 100, j cap 010, k cap 001. So 2 into 1 vector from your basis, 3 into 1 vector from your basis, 4 into 1 vector from your basis. So in this space, every member is possible to express combination of these three vectors. That's why this XYZ space, that is called three-dimensional space. For that three-dimensional space, this is the basis, because basis contains basic vectors. What are the basic vectors? I cap, j cap, k cap. Now, main thing, any problem is given on this basis concept, you have to check only one condition. What is that condition? Whether vectors are independent or not. That gives you complete picture. Okay? Observe. After completion of the problems on this concept, rank and basis this concept, after that I'll explain system of linear equations. Okay? Now, yesterday I have explained you how to reduce a matrix in echelon form. Saini, if you understand what is the standard basis, you can understand the concept. If you are feeling tough about this standard basis concept, sir, is it always in the form of 100? If you understand 100 concept, you can understand some other vectors concept. Any three independent vectors, if you take in your basis, you can express any vector in the form of combination of those three. Okay, I have taken only simple example. Simple example is only this example is standard basis concept. Just to get the idea about basis. Okay? Observe the problem. Arvind Kumar, the basis question is also in these slides. Okay? I'll explain. Yeah. 1487 0030 4231 312 24 2. That is the given matrix. Okay. First you have to write given matrix. Raghunath Yadav, vector space V contains infinite number of vectors. In that infinite, some independent, some dependent. I never said they are all dependent. They are all independent and dependent combiningly available in your vector space. We are not interested about vector space. We are interested about basis. Vector space consisting infinite number of vectors. Now, observe this problem. First, you have to find rank of this matrix. 1/1 entry is 1. When 1/1 entry is 1, you have to start a right angle triangle from second row onwards. Reduce all the elements covered by right angle triangle 0 by using operations. Okay. Now, I am applying the operation R3 minus 4R1. R3 minus 4R1. R3 minus 4R1. R4. When you look at R4 and R3, we found that they are proportional. That's why R4 minus 3 times of R1. Write first row as it is. First row is 1487. Wait. Next I will come for shifting. Second row 0030. Next 4 minus 4 0. 4 minus 4. I am talking about this operation. R3 minus 4 times of R1. 4 minus 4 0. 2 minus 16 minus 14. 3 minus 32 minus 29. 1 minus 28 minus 27. Fourth row and third row are proportional, therefore, right? Fourth row and fourth row and I have written 3R1, 3 times of R1, 3 4 ja 12, 3 8 ja 24, 3 7 ja, it is not complete 0, you will get 3 zeros. Minus 19. Now, interchange R2 and R3. By interchanging R2 and R3, you will get 1487. 0 minus 14 minus 29 minus 27, 0 0 3 0, 0 0 0 minus 19, rank 4. It is an echelon form. Rank of A is 4. This problem yesterday we have discussed. All the rows are proportional, therefore rank is 1. This problem, rank is 1. Yesterday we have discussed this problem. You know the answer, but understanding the data, some students get confused. x1, x2, xn is n-tuple non-zero vector. Most of the students' concentration is on this concept. What is n-tuple? Already one question we got. N-tuple is nothing but n-dimensional. N-dimensional vector. N cross 1 vector. That is the meaning. N-tuple, n-dimensional. So, X is x1, x2, x3 and so on, xn, n cross 1 non-zero vector. That is the given statement. If it is a n-dimensional non-zero vector, if the vector is an n-dimensional non-zero vector, what is its rank? Rank of x, 1. If rank of x is 1, rank of x is 1. Rank of x transpose 1. Rank of x into x transpose 1. Rank of x transpose into x 1. That's why answer is 1. Understood? Observe this problem. Tell me the answer. Two matrices A and B are given below. A is PQRS, B is P square plus Q square, PR plus QS, PR plus QS, R square plus S square. Then what is rank of B? Very good. Same concept. Yes. Rank of A is n. Given that rank of A is n, where A is PQRS. So what I am doing, I am going to calculate A into A transpose. Multiply P square plus Q square, PR plus QS, PR plus QS, R square plus S square. It is nothing but matrix B, na? That's why this is nothing but B. We know that rank of A and rank of A into A transpose are equal. Therefore, this is equal to n because rank of A is n. If rank of A is n, rank of A into A transpose is also n. That's why rank of B is also n. since B is A into A transpose. That's why. Observe here. Matrix P is provided, matrix Q is provided. P and Q are two matrices. Then what is the rank of P plus Q? In matrix P, 1, 1 minus 1, 2 minus 3, 4, 3 minus 2, 3. One point I have to clarify. The problem is designed based on one concept. Just to trap you, the problem is designed like this. Some students calculates rank of P. Siddharth. Some students calculates rank of A, some students calculate rank of B, and by using A and B or P and Q, they are going to fix the answer. That is 200% mistake. You should not do. You should not go by that path. You should not calculate rank of P and rank of Q. First, you have to calculate P plus Q. Most of the students will be trapped by this logic. Yeah, first they will calculate rank of P, rank of Q, they will add, then gone. Sir, in Q, two rows are identical or two columns are identical, so rank is very easy. You should not calculate in that manner. Rank of P plus Q less than or equal to rank of plus rank of Q. So less than or equal. That's why you should not calculate rank of P separately, rank of Q separately. Durgalal, I am talking about that point only. You should not calculate rank of P, rank of Q. You have to calculate first P plus Q. Remember. First add P and Q. 1 minus 1, 0. 1 minus 2, minus 1. Minus 1 minus 1, minus 2. 2 plus 6, 8. Minus 3 plus 12, 9. 4 plus 6, 10. 3 plus 5, 8. 10 minus 2, 8. 5 plus 3, 8. Now, do one thing. Apply the operation. R3 minus R2. 0 minus 1 minus 2. 8, 9, 10. 8 minus 8, 0. 8 minus 9 minus 1. 8 minus 10 minus 2. Now, R3 minus R1. 0 minus 1, 2. 8, 9, 10, 0, 0, 0. Interchange R1 and R2. 8, 9, 10, 0 minus 1 minus 2, 0, 0, 0. Therefore, rank of P plus Q is 2. Understood? Suppose if you calculate rank of P and rank of Q separately and if you add, you will get 3. That is not the answer. You should not calculate rank of P and rank of Q. You have to calculate first P plus Q. After that, you have to calculate rank. Murali, completed? Punjabi, can we take 8 common? From where? From where? It is a matrix. Mukherjee, it is a matrix. It is not determinant. From matrix, if you would like to take an element common, you have to take it common from each element. From determinant, you can take it common from each row or any column. Understand the difference between matrix and determinant. It is concept based question. Mr. Ishant, if you want to get echelon form, you have to interchange R1 and R2. If you interchange R1 and R3, what is the use? Again, you have to interchange. 2 more steps increases. It is concept based question. Observe. Rank of 5 cross 6 matrix is 4. Rank of 5 cross 6 matrix is 4. Instead of copying, concentrate here. Rank of 5 cross 6 matrix is 4. Okay. Then, which of the following statements is correct? Which of the following statements is correct? 1 minute, I have to clarify. Avadesh, I never said if 2 rows are identical, rank is 1. I never said. Yesterday, I have explained that point 10 times. Yesterday, I have explained that point 10 times. If 2 rows are identical, determinant is 0, rank is less than n. Rank is not 1. If all the rows are identical, then only rank would be 1. Don't misunderstand the concept. Wherever there is a chance to commit mistake, definitely I'll warn. Not once, 2-3 times. I never said 2 rows are identical, rank will be 1. I said if 2 rows are identical, rank is less than its order because determinant is 0. If all the rows are identical, then only rank is 1. Always 1. Avadesh, got it? In the previous question, 2 rows are identical. If all the rows are identical, then only rank is 1. Come here. Concentrate. Whether A is the answer or B is the answer, we can decide. Concentrate. Matrix Q, a 5 cross 6 matrix Q has rank 4. Then which of the following statement is correct? 4 linearly independent rows and 4 linearly independent columns, or 4 linearly independent rows and 5 independent columns? Nitya, even though you perform column operations or row operations, you will get rank is unique, either row or column. Please cross check. You might have done some mistake. Rank 2 only. Nitya, even though you cross check 10 times, you will get rank 2 only. Please cross check the entries. Once row operation, once column operation, you should not do. Completely row or completely column. Now, concentrate here. A matrix 5 cross 6. 5 cross 6 with rank 4. Please remember, rank declares number of independent vectors. Finish. Determinant of Q is 0 now. It is a 5 cross 6 matrix, man. 5 cross 6. You have to go by rank procedure only. Already rank is given. Why you are calculating that Q? Already rank is 4. You need not to calculate anything. You have to identify the concept. If rank is 4, the logic is 4 linearly independent vectors. Sir, 4 linearly independent column vectors or row vectors? 4 linearly independent row vectors or column vectors? Both. Very good. Because I have applied row operations. I found that 4 non-zero rows. Some other student is applied column operations. He got 4 non-zero columns. He found that rank 4. I have applied row operations. I found that 4 non-zero rows. So rank is 4. According to my operations, I can say there are 4 linearly independent row vectors. Suppose some other student has applied column operations and he got column echelon form. He found 4 non-zero columns. He will say 4 linearly independent column vectors. So rank declares not only independent row vectors but also declares independent column vectors. That's why, please remember, rank is 4 means there are 4 linearly independent rows as well as 4 linearly independent columns. That's why first option is correct. Whenever you are solving a concept based question, you have to be very careful. Muhammad, what is inversible? Surabhi, what is inversible? Vikas, what is inversible? Inversible matlab inverse exists. When inverse exists, determinant non-zero hai to inverse exists. Previous slide, nothing, only slide is there. I have selected the answer. Concept I have explained. Observe. Let U and V be 2 vectors in not R2, R square. R square. Okay. Whose Euclidean norms satisfies norm U equal to 2 into norm V. Don't worry about norm. Norm is nothing but length. Length of vector U equal to 2 times of length of vector V. Avdesh, Euclidean norm, length, all are same. Same point I am explaining. Okay. What is the value of alpha such that W equal to U plus alpha V bisects the angle between U and V? Observe here. U and V are 2 vectors in R square. Concentrate here. 2 vectors in R square. R square means 2-dimensional space. Given that xy plane, given that U is equal to 2 times of length of U equal to, hello Murali, R square means a plane, XY plane. You understand in that way, XY plane. On XY plane, U and V are two vectors such that length of vector U equal to 2 into length of vector V. 2 times of length of vector V equal to length of vector U. Okay. Now, that's why I am assuming U as 20, V as 01. Because if I calculate length of U, I will get square root of 2 square plus 0 square. That is nothing but root 4. That is nothing but 2. Now, what about length of V? Square root of 0 square plus 1 square, that is 1. Now, length of U is 2 times of length of V. Satisfying or not? Now length of U is 2 times of length of V. Sir, why you have taken 2001 to satisfy this condition? Sir, why you have taken 01? Here, my vector space is 2-dimensional vector space. That's why I have taken actually 1001. But a condition is norm U equal to 2 times of norm V. Length of U equal to 2 times of length of V. That's why 2001 I have taken. Now, given that what is the value of alpha such that W is U plus alpha V? So what is W? Given that W is U plus alpha V. So what is U? 20. What is V? 01. So alpha into 01. That is 2 plus alpha into 0 is 2. 0 plus alpha into 1 is alpha. That is 2 alpha. W is 2 alpha. Okay. Now I am going to write one statement. What is that statement? Clearly he has mentioned that W bisects angle between U and V. Bisects means, so angle between U and W and angle between V and W are equal. So I am writing let theta 1 be the angle between U and W, theta 2 be the angle between V and W. Given that theta 1 equal to theta 2, therefore cos theta 1 equal to cos theta 2. If theta 1 is theta 2, then cos theta 1 is cos theta 2. Sir, why you have taken cos theta 1 and cos theta 2? We have dot product formula. Okay. Dot product between two vectors. A bar dot B bar equal to mod A bar into mod B bar cos theta. I would like to use that formula. Okay. Now, cos theta 1 is nothing but U bar dot W bar by mod U bar into mod W equal to V bar dot W by mod V bar into mod W length. Okay. Sir, what is U bar dot W? You know U and W? U is here, W is here. Okay. Not understanding. That is your problem. Concentrate. Don't write. You don't write. Concentrate here. Then you will get it. I have not explained anything. What is given, I have written. They have given length of u equal to 2 times of length of v. That's why I have assumed like this. How to calculate length? Square root of first component square plus second component square. Root 4, that is 2. Okay. Length of v, square root of 0 square plus 1 square, that is 1. Clearly, this u and this v are satisfying this condition. Sir, where I got this condition? This condition is given in the data. Given that. Sir, what is w? That is also given in the data. Given that w equal to u plus alpha v. U I have substituted, v I have substituted here. Alpha is not 2. I have not solved the problem. Just I am explaining now. 2 plus alpha 0 is 2. 0 plus alpha into 1 is alpha. Do you understand till here? At least one slide. I am coming to second slide. Before that, I will calculate what is u bar dot w and v bar dot w. After that only I will move to next slide. Now, u bar dot w equal to, what is u bar? Mod u bar into mod w bar cos theta 1. Chandani, from where I have taken u and v? I have assumed. It is not given in the data. I have assumed u and v. How to assume u and v? They have given a hint here, r square. Based on that, I got that idea. Now, dot product of two vectors is a formula. U bar dot v bar equal to mod u bar into mod w bar into cos theta 1. Okay. Now, sir, what is u? I have already given. U is 2, 0. What is w? Just now we have calculated 2 alpha. Okay. 2 alpha. Now, what is v? 0, 1. 0, 1. Okay. What is u bar dot w and v bar dot w? I am calculating. Okay. Now, u bar dot w means dot product between u and w. You calculate here. U and w are known, na? U bar dot w is nothing but take u transpose 2, 0, w 2 alpha. Take inner product. You know how to take inner product. You have to take transpose of u. Because they must be comfortable for multiplication. Result must be 1 cross 1. Okay. If you multiply, you will get 2 into 2, 4 plus 0. That is 4. I'll write with yellow color only. Okay. U bar dot w is 4. Similarly, v bar dot w. V is 0, 1. If I have to write like this, that's why I am taking transpose. 2 alpha. Multiply 0 plus alpha. That is alpha. Okay, I have calculated dot product between u and w and dot product between v and w. Sir, why you have calculated dot product means he has mentioned that w bisects u and v. That's why angle between u and w and angle between v and w are equal. That's why I have taken here theta 1 is angle between u and w, theta 2 is angle between v and w. Therefore, theta 1 equal to theta 2. Cos theta 1 equal to cos theta 2. Cos theta 1 is nothing but u bar dot w by mod u bar into mod w. V bar dot w by mod v bar into mod w bar. Got it? Understood? Now I have to substitute here. U bar dot W is 4 by mod U bar. I have calculated here. What is mod U? 2. What is mod W? I have not calculated. I have to calculate. Mod W is square root of 2 square plus alpha square. That's why I am writing here square root of 4 plus alpha square equal to V bar dot W alpha by mod V bar. Mod V bar. Mod V bar is 1. So 1 into square root of 4 plus alpha square. Understood? Do you understand this step? Now what you have to do? Square root of 4 plus alpha square, square root of 4 plus alpha square, you have to cancel. 4 by 2 is equal to alpha by 1. So 2 is equal to alpha. Answer is alpha equal to 2. If anyone, Mr. Akhtar, U transpose W, I have explained yesterday. How to calculate inner product, I have explained yesterday and day before yesterday. Why you have to take U transpose dot W? If you want to calculate dot product between U and W, U is a column vector, W is also a column vector. Dot product between two column vectors, if you would like to take, you have to take transpose of one vector. Only for calculation of dot product, we are going to use the technique. I never said U transpose W and U dot W are equal. It is a conceptual. How to calculate dot product, inner product. Mr. Raju, you need not to identify angle is same. We have not identified angle is same. It is the given in the data. Bisects. Bisects. Matlab, angles are same. Bisecting. Bisection. Angles are equal. It is not my assumption. It is given in the data. Observe this problem. The set of three vectors linearly dependent, then what is the value of x? If vectors are linearly dependent, what is the value of x? Here, you have to use the concept of independent vectors, dependent vectors. The best method is take determinant and equate to 0. Okay? Right. Given that three vectors are linearly dependent, since they have given dependent, I am taking det A equal to 0. Arrange the vectors in the matrix 1, 2, 1. X, 6, X. 3, 4, 2. Equal to 0. Expand determinant. 1 of 12 minus 4x minus x of 4 minus 4 plus 3 of 2x minus 6 equal to 0. That implies 12 minus 4x plus 6x minus 18 equal to 0. 2x minus 6 equal to 0, x equal to 3. The value of x is 3. There are 4 methods. I have explained you 4 methods. Okay, you can apply any method, whichever method you feel convenient. I have to explain a method. 90% of the students should understand that concept. Question slide. This is the question. If the vectors are dependent, what is the value of x? I have equated determinant to 0. Understood? राजू, वो इंडिपेंडेंट में आता तो डिटरमिनेंट नॉन जीरो होता था. Observe. Let x and y be, let x and y be two vectors. Very conceptual problem. Let x and y be two vectors in a three-dimensional space. X dot y denotes their dot product, inner product. Then the determinant, he has given the determinant with inner products, is 0 when x and y are independent, is positive when x and y are independent, is non-zero for all non-zero x and y, is 0 for all either x is 0 or y is 0. Concentrate. Excellent problem. Most of the students get confused. They have provided a determinant. Whether this determinant is 0 or non-zero, we have to find out. X dot x, x dot y. Y dot x, y dot y. Concentrate here. Use the, here x and y are not x-axis, y-axis. Here x and y, please understand. Here x and y are x-axis, y-axis 9. You should not assume like that. Two vectors, we don't know. What are the vectors? We don't know. Unknown. Okay, concentrate here. Determinant. Just I am using the definition. X dot x. X is one vector, x is another vector, dot product between two vectors x and x. X and x means same vectors, na? X and x are same vectors, na? That's why I am writing the definition of dot product. Mod x into cos theta. Sir, what is cos theta here? If x is one vector, other x is also same vector, then what is angle? 0, na? That's why cos 0. Next, x dot y. X and y are two non-zero vectors. What is the dot product between x and y? Mod x into mod y into, some students writes cos 90. Don't write cos 90. That same point I said 10 times. X and y are not x-axis, y-axis. X and y are two different vectors. Cos theta. Don't misunderstand the concept. Any angle, we don't know. Angle is unknown. Sir, here you have written theta, here you should write theta. Here x and x are same vectors, na? That's why angle is 0. Here y and x, mod y mod x cos theta, mod y cos 0. Okay, understood? Continuation. Mod x into x, mod x square, cos 0 is 1. Mod x into mod y into cos theta. Mod y into mod x into cos theta. Mod y ka whole square. Okay. Now, you know that how to calculate determinant value. AD minus BC. This product minus this product. That gives us mod x whole square, mod y whole square minus mod x whole square into mod y whole square into cos square theta. You take mod x whole square, mod y whole square common. Mod x whole square, mod y whole square of 1 minus cos square theta. Mod x whole square, mod y whole square, 1 minus cos square theta is sin square theta. Look at the entries. Mod x whole square, 100% positive. Mod y whole square, 100% positive. Sin theta whole square, 100% positive. So all are in square form, na? Therefore it is positive. Positive means determinant is non-zero, na? Positive is nothing but determinant is non-zero or not? Determinant is non-zero. If determinant is non-zero, if your determinant is non-zero, then independent or dependent? Independent or dependent? Linearly independent. So, final conclusion is vectors are linearly independent and determinant value is positive. Positive and vectors are linearly independent. Positive का मतलब 0 नहीं, positive मतलब greater than 0. सार्थक वो 90 नहीं बाबा. You are misunderstanding the concept. It is not 90. X and Y are two non-zero vectors. Two vectors in a three-dimensional space. That's why correct answer is Laksh. Whether theta can be 0 or theta can be non-zero. Here X and Y are two vectors in a three-dimensional space. You are talking about sin theta ka value. You should not think about sin theta value here. His question is, if you take all four entries are in a dot product manner, whether determinant value is positive or negative or 0 or non-zero, it is a conceptual question. Option D, nahi. It is not option D. Option D is a trap. सर x 0 है तो y 0 है तो सारे 0 है तो एक पॉइंट है वो. Our job is not to think about theta. Our job is to analyze if x and y are two non-zero vectors in a three-dimensional space, their inner product combination gives you determinant 0 or non-zero, determinant positive or negative, whether vectors are independent or not. Please observe, in this PDF copy, I have selected the questions wherever most of the students get confused. All are previous gate questions only. Typical questions only I have selected and posted here. Most of the people leave all these typical questions. I am explaining purposefully because 90% of the students commit mistake only these typical questions. If you know about the concept, then only you can answer. Observe this problem. Q1, Q2, Qm are n-dimensional vectors with m less than n. What is m? Number of vectors. Number of vectors are m. Each vector is of dimension n. Components are n, but vectors are m. Suppose two vectors, if you take like this, if you take two vectors like this, 1, 5, 7, 2, 1, 3, 2, minus 1. Here, vectors are only two. This is x1, x2. But dimension of each vector, 4 na? So 2 less than 4 are not. Number of vectors are 2. Dimension of the vector is 4. Similarly, here Q1, Q2, Qm are n-dimensional vectors. Number of vectors are less than n. Okay. Number of vectors are less than its dimension. The set of vectors is linearly dependent. It is very, very important point. Very, very important point. Linearly dependent. Please remember, set is linearly dependent. Keep in mind, set linearly dependent. When we will set is linearly dependent, at least one is dependent, then set is linearly dependent. Catch my point? Yes, very good. Now, matrix Q is formed by these m vectors. Matrix is arranged with these m vectors. So, what is the concept? I have given m vectors. You have arranged in a matrix. We found that rank of that matrix is less than m. Catch my point? I have given 10 vectors. I have given 10 vectors. You have arranged in a matrix. You calculated the rank. Rank is less than 10. Then only that is dependent. Na? Got the point? So completely it is designed based on concept. So what is the answer? What is the answer? Less than m. Less than m. Janki, any problem is designed based on the concept, they will apply the logic. So here problem is designed based on the concept of dependent. If it is independent, they have to specify with rank m. Next, let excellent question. You won't get the idea. By reading this problem, you won't get the idea. Read the problem. Let P be a real orthogonal matrix. X bar is a real vector. X1, X2 transpose. Length is given. You know how to calculate length. It is a real vector. Okay. Then which of the following statement is correct? You have to analyze the given statements. What are the statements? In the statement they have given length of px bar and x bar, they have compared. Whether length of px bar and x bar are equal or less than or greater than or equal, we have to find out. Here keyword is because very good. orthogonal matrix. If you want to solve this problem, you have to take one orthogonal matrix. That is the keyword. Okay. C hoga or B hoga or A hoga, we can discuss. Okay. Mainly, you have to concentrate on the content. How to process the data. Here, matrix is orthogonal matrix. So, to solve this problem, you have to take one orthogonal matrix. Orthogonal matrix. Contains orthonormal vector, that is a matter. That is the property of orthogonal matrix. Main thing is you have to take one orthogonal matrix and you have to examine the condition. What are the conditions given in the data? You have to check Px bar, x bar. Finally, your goal is to calculate Px bar and x bar. You have to assume the relation between Px bar and x bar. Okay, concentrate. I have given you one beautiful example in the case of orthogonal matrix. Remember cos theta, sin theta. Did you remember? You have to, that is the standard orthogonal matrix. That's why here he has mentioned clearly 2 cross 2. I am going to take 2 cross 2 only. Bharat, your job is not to calculate A into A transpose, Baba. A into A transpose is I is a property of orthogonal matrix. Should not. This problem is not at all designed on that concept. The problem is designed on length. Observe. Let matrix P equal to cos theta sin theta minus sin theta cos theta. Sir, why you have taken this example? Given that matrix is orthogonal, that's why I have taken this example. Given that P is 2 cross 2 orthogonal matrix. That's why I have taken this example. Now, I am calculating Px bar because I have to develop the relation between Px bar and x bar. That's why I am calculating Px bar. Multiply cos theta sin theta minus sin theta cos theta with x1 x2. Multiply, you'll get x1 cos theta plus x2 sin theta minus x1 sin theta plus x2 cos theta. Now calculate the length of Px bar. Norm Px bar is nothing but length of Px bar. How to calculate length? Square root of first component square. What is first component? x1 cos theta plus x2 sin theta ka whole square plus second component whole square minus x1 sin theta plus x2 cos theta whole square. Okay, now square root of x1 square cos square theta plus x2 square sin square theta plus 2x1 x2 sin theta cos theta plus x1 square sin square theta plus x2 square cos square theta minus 2x1 x2 sin theta cos theta. These two are under cancellation because of plus minus. That is square root of, observe, x1 square cos square theta, x1 square sin square theta, x1 square, x2 square sin square theta, x2 square cos square theta, x2 square. What is this? Norm x1. So the relation is length of px bar equal to length of x bar for all vectors x bar if the matrix is orthogonal matrix. Understood? Got the point? Okay, this is a problem designed on system of equations. So I have to explain the concept of system of equations. After that, we can discuss this problem. Any queries? Can we directly find determinant of Ka when K is a scalar and A is a matrix without multiplying K in A? You want to find out determinant of Ka. K is a scalar, A is a matrix. Without multiplying K in A, how you are going to get Ka? Without multiplying K in A, how you are going to get Ka? Ka equal to K power n into det A. This is the property. Next. Please explain if determinant of A is 0 condition linearly independent vector. Laksh. If determinant is 0, I never said linearly independent vector. If determinant non-zero hai to linearly independent vector. If determinant of A is non-zero, then set is linearly independent. If determinant of A is 0, then set is linearly dependent. Okay. Next. One, two, three, four, 1, 2, 3, 4. R2, R1. Mr. Nitin, properties of determinants are different, properties of rank are different. You are merging properties of determinant with rank. Observe. If you take 1, 2, 3, 4, what is your purpose? Are you going to find determinant value or are you going to find rank? If you would like to find rank, whether you interchange 1, 2, 3, 4, 3, 4, 1, 2, no problem. You can interchange. R1 interchange with R2, no problem. You can interchange. 3, 4, 1, 2, no problem. Rank does not change. Suppose in determinant 1, 2, 3, 4, here determinant value is 4 minus 6 minus 2. If you interchange 3, 4, 1, 2 like this, 6 minus 4, 2. Sign changes. Numerical value same. Sign changes. Okay. Interchanging of two rows while finding rank, it doesn't affect the rank. While calculating determinant value, its numerical value same, only sign changes. Okay, next, another query. Nehal Mehta. What is X bar in the question that we resolved, in which had to take orthogonal matrix? Norm or mod, both are same. For n-dimensional vector, we are going to represent by norm. For 3-dimensional, we are going to represent by mod. Underlying concept is same. Mod x or mod x bar or norm x bar, all are equal. Just you have to calculate length. Suppose x is x1, x2, x3. Then norm x is square root of x1 square plus x2 square plus x3 square. That is the meaning. Please explain last second problem. Okay. Last second. Last second is this one. Okay, this one. Murali, observe. This is nothing but they have provided m vectors of dimension n. You have arranged first vector q1 like this, q2 like this, qm like this. After arranging the vectors in a class is over. Tomorrow we can discuss about system of equations. Okay, Soras? Now I am clarifying the doubts. Q1, Q2, Qm. You have m vectors. You have arranged in a matrix. Applied the operations. You have applied the operations. Clearly they have mentioned that m less than n. What is maximum possible minor here? Maximum possible minor is minimum of m comma n. They have mentioned that clearly m less than n. If m is less than n, compulsory maximum possible minor is m cross m. Okay, Murali, got it? Maximum possible minor is m cross m. If maximum possible minor is m cross m, maximum possible rank is m. Maximum possible rank is m. If maximum possible rank is m, okay. Suppose rank is m, then you can say that maximum possible minor is non-zero, therefore rank is m, therefore you can say that all m vectors are linearly independent. But in the data it is given that the set of vectors are linearly dependent. Maximum possible minor is m cross m. So maximum possible rank is m. If maximum possible rank is m, if rank is m, you can say that m independent vectors. But they have provided that the set of vectors are linearly dependent. If the set is linearly dependent, given that set is linearly dependent, so by this statement we can understand that rank is not maximum. Rank is less than that. That's why you can write rank of A is less than M. Understood? Murali? Suppose your matrix is 10 cross 20. Maximum possible minor is 10. If maximum possible minor is non-zero, rank is 10. All 10 vectors of dimension 20 are independent. But they have provided that rank is less than its order. Rank is less than its maximum possible minor. Because they have given that linearly dependent. Okay, next. Manish, in mathematics, there are various methods. Okay, I have applied bisection method. I have taken cos theta. You are talking about tan inverse. You can take, no problem. Sir, explain first or third option in the last question. First or third option in the last question. This is our last question. Orthogonal matrix wala. Already I proved that both are equal. Then there is no discussion about less than and greater than. When exactly they are equal, what is the discussion about greater than or equal? Greater than is not valid, na? Less than is not valid, na? That's why that is ruled out. Okay. Thank you. Good night. Yes, Vijay.